Okay, so our next video is going to talk about the cubic function. The cubic function is a function that grows really, really quickly. It doesn't go quite as quickly as something like exponential growth or decay because what's changing, the x value is not in the exponent, right? Our exponent is always 3 in a cubic function. But as you can start to see, this grows a lot quicker than something like a quadratic or something like a linear line or something like the absolute value parent function. So when we talk about a cubic function, let's kind of see what inputs and outputs are we looking at here. Okay, well, let's always start at 0. When you cube 0, you just get 0, right? 0 times 0 times 0, or 0 to the third power, is just 0. When we look at 1, when x is 1, well, 1 times 1 times 1 is just still 1. Okay, so as you can see, hasn't really made much movement. Okay, well, what happens when x is 2? Well, 2 cubed we know is 8, or 2 times 2 times 2. And then let's just skip one more, right? Let's go to 3. Well, 3 cubed, 3 times 3 times 3, it's not 9, it's actually 27. So if you look, we've just made another huge jump. Okay, so then let's talk about this as we go backwards. When x is -1 and you raise -1 to a power of 3, it's an odd power. So -1 times -1 is +1 times -1 is -1. So because it's a cubic function, when x is negative, your output is also going to be negative because it's being multiplied by that odd degree. And then when x is -2, our output is also -8 because of that exact same reason. So let's plot these points. Let's see what this graph looks like. Here we have 0, 0. We have 1 to 1. We have 2 to 8. Okay, 1, 2, 3, 4, 5, 6, 7, 8. And if you look, it's right there. 3 to 27 is somewhere all the way up there. So we're not even going to worry about plotting that. And then we can go backwards, -1 to -1, -2 to -8. And so if you look, the graph of the parent function of a cubic function looks like this. It is it almost looks linear. Sometimes you might see it like this if it's moving backwards. It almost looks linear, but it does have this curve that's going on right here. And what's happening is that obviously when x is smaller, the jump isn't as big. But as soon as x gets bigger, the jump is getting bigger and bigger and bigger each time. So that's why this cubic function grows really quickly. And as you can see, it grows really quickly and it almost looks like it's at that really steep incline or decline, which is what's happening here. It grows a little bit slower and then boom, it just skyrockets. So what are some key points on the parent function? Well, obviously we've been starting with 0, 0. Okay. And really you're just always cubing whatever x is. So 1 to 1, 2 to 8, right? 3 to 27, -1 to -1, -2 to -8, and so on and so forth. So these key points of the parent function will always be there. Now, if you have an a value, if you have this, are you adding 4 at the end? Are you dividing x cubed by something? Obviously it's going to shift what the graph looks like, and it's no longer going to look like the parent function, but these key plotted points will always be there. Now, let's talk about domain and range. As x moves to positive infinity, y is moving up. There's arrows. And as x moves to negative infinity, y is moving down, and there's arrows. So actually, your domain and range is going to be all real numbers for both the domain and the range. Because x really can be, you can cube any number. You can cube a negative number, you can cube a positive number, and you will get those inputs and outputs that can go from negative infinity to positive infinity. So cubic parent function, it is important that we understand what the shape looks like. It's like this curvy looking graph that just grows and skyrockets either way. We know it crosses through the origin at 0, 0, and we know that it grows really, really quickly. All right. We have one more function to look at. We're going to head down to the bottom of this page and we're going to check out the square root function.